Hello friends. Welcome to our channel Instrumentation Technical Studies. Let's start our today's topic RTD. Before going to RTD, let's discuss the metals resistance property. All metals resistance has two conditions with temperature change. The first one is positive temperature coefficient. In PTC, whenever the temperature increases, the resistance of metals also increases. And the second one is negative temperature coefficient. In NTC, whenever the temperature increases, the resistance of metals decreases. These two conditions are used to measure the temperature. Our today's topic is RTD, which comes in positive temperature coefficient, so let's discuss deep into RTD. The main advantage in PTC is its linearity. Observe the graph. Whenever the temperature increases, the resistance is increasing linearly. Linearity means the change in resistance is equal for every degree change in temperature. We are always talking about resistance change. But how much it will change for 1 degree change in temperature? It can be explained by the following formula. The following formula defines the relation between resistance and temperature change, where RT is resistance of RTD at given temperature T. R reference is resistance of RTD at the reference temperature T reference. And alpha is the temperature coefficient of resistance. These are some of the coefficient values for different metals. Among these, platinum is normally used because of its advantages, and platinum can be represented by P/T. Platinum is the mostly used material for RTD. There are plenty of advantages in platinum for design RTD. Some of them are broad temperature range. That is, its melting point is 1700. So platinum can be used for a wide range of temperature measurement. It is very stable, does not oxidize easily. That is, it cannot react with any gas or liquid to create a hazardous situation. It has very good repeatability, means for a fixed temperature point, it will repeat the same resistance value for n number of times. So, finally, because of its advantages, platinum is finalized to construct the RTD. This is the practical diagram of a RTD. The platinum is present at the tip. But here comes the main problem. By which shape the platinum should be deposited at the tip. For that, RTD has two types, thin film, and wire wound. Let's see the constructional diagram. Of a thin film, it can be constructed by depositing a thin layer of platinum metal in a ceramic substrate, and two wires are taken from opposite ends. Again, it has two types. First one is thin film. It is used for temperature from -50 degrees centigrade to 400 degrees centigrade. And the second one is thin film high temperature. It is used for temperature ranges from -60 degrees centigrade to 600 degrees centigrade. Mostly thin film type is preferred in vibration and physical shock areas. And the second type is wire wound type RTD. Observe the constructional diagram of wire wound RTD. Here a platinum wire is wounded on a ceramic bobbin, and two leads are taken from opposite ends. It is preferred for the temperature range of -196 degrees centigrade to 300 degrees centigrade. It is basically preferred for low temperature applications. In an industry, the RTD from field is connected to transmitter at a length L. Let's see the practical circuit diagram. Here resistance of RTD is need to be measured in order to find out the temperature. But as this RTD is connected through wires, which are in series, so the total resistance transmitter measuring is RTD resistance plus 2 multiplied by resistance of wire. In order to remove this wire resistance, there comes a reference resistance into picture. In order to get clarity about this, see the formula which we had discussed earlier. Here we have two reference values. One is temperature reference value. Normally reference temperature is fixed as water freezing point, that is 0 degrees centigrade. And the second one is R reference, which is the resistance of RTD at 0 degrees centigrade. In this we have three main types of RTD. They are PT100, PT 500, PT 1000. In this PT stands for platinum and value represents the resistance value at 0 degrees. Let's see the values as PT 100 and PT 1000 at different temperatures. Observe the values at 0, 1 and 2 degrees centigrade. Simply the PT 1000 values are multiplied by factor 10, so let us assume the lead resistance to be 2 ohms. That covers 2% in PT 100, and 0.2% in PT 1000, which is negligible. Though the lead resistance is negligible in PT 1000, it is not preferred for long temperature ranges, and its cost is very high compared to PT 100. So they had gone for another model to reduce the lead resistance. Now next step to reduce the wire resistance. We had taken 4 wires, which are connected to opposite sides of platinum. In this the 4 wires are connected into 2 circuits, as shown in the figure. In this the first circuit provides the constant current, irrespective of RTD resistance, which causes some voltage to drop in RTD. This voltage is picked up by other 2 wires. By this we can find the resistance with Ohm's law. Here lead resistance is eliminated, because in the first circuit, the wire resistance and RTD are in a single loop, so same current will pass, and the other 2 wires has minimum voltage drop, because the voltmeter have high resistance, which allows very low current to pass. It is good, but number of wires are becoming more. Let's see, for 1 RTD it need 4 wires, for example if plant contains 1000, then, so in next model 1 more wire is reduced. In a 3-wire RTD circuit, we have a constant current source irrespective of resistance of RTD, same as in 4-wire, but here we have 2 voltmeters, voltmeter A, and voltmeter B. In this the voltmeter A measures the voltage dropped across the RTD plus, the voltage dropped across the bottom current carrying wire. Voltmeter B measures the voltage dropped across the top current carrying wire. Assuming both current carrying wires will have the same resistance, subtracting the indication of voltmeter B from the indication given by voltmeter A gives the voltage dropped across the RTD. By using the Ohm's law we can calculate the resistance of RTD. This is the most preferred RTD among all. Thank you for watching. If you like this video please like, share, and subscribe.